Good afternoon, Mondo. In the today's class of this machine tools and machine cutting, we'll be discussing the types of cutting processes existing in the case of this MRR and different agitations related to the MRR, such as chip formations and types of metal cutting processes. Coming to the types of these metal cutting processes, it has been mainly classified into two groups. First one is the orthogonal cutting process and oblique cutting process. So orthogonal is the two-dimensional cutting process in which the cutting edge or the face of the tool is about to 90 degrees to the line of the action or path of the tool. Nothing but a best example related to it is our lathe machine, the conventional lathe machine, which we'll be utilizing in our laboratory process also. This cutting involves only two forces, which makes the analysis very much similar. That is cutting forces and speed. Coming to this point of this oblique cutting, it is three-dimensional strategy. The cutting edge or face of the tool is inclined at less than 90 degrees to the action of the path or the velocity that is being maintained by the work part, which has been fixed in the machinery chunk. When compared to the two-dimensional system or analysis or working process in the case of this two-dimensional system, this three-dimensional system is a bit difficult, but the results are very much feasible in the case of this three-dimensional. Coming to the basic difference between these two, there is orthogonal and oblique cutting. While turning the ductile materials by sharp tools, nothing but the form of machining process which will be progressed continuously upon removing the material, such as a lathe machine. The chips would be overflown through the tool's rack surface by removing the small chips, that is under MRR process, by the contact of this tool with respect to the work part. And even that miniature chips will be overflown to the rack of the surface, in which the direction apparently perpendicular to the principal cutting. So we are all aware that in the orthogonal cutting, the tool and the work part machining condition will be exactly maintained with respect to 90 degrees. The stepwise cutting, or else the knurling process will be getting progressed by this orthogonal plane, which will be normal to the cutting plane that contains the principal cutting edge. But in practical, the flow of these chips along the orthogonal plane for several factors like the inclination angle, etc. Its role of inclination or the chip flow, which is shown in the diagram here, orthogonal cutting, upon removing of the material by a small feeding. When the feed rate or inclinational factor lambda is 0, the flow of chips in the case of orthogonal plane is 0. There will not be any removal happening. It is not equal to 0, slip flow will be getting deviated with respect to the orthogonal plane also. That is limited towards the lambda. And here in the diagrammatical process, it's very much clear that the orthogonal plane, which is being existed within 90 degrees of range of cutting perfectly here by maintaining the rack angle exactly opposite with respect to the work part. This is the work part which is placed, and exactly by maintaining perpendicular axis, that is 90 degrees. See here 90 degrees it is being maintained and machining conditions will be progressed by imparting a feed. So in the case of this oblique cutting, so oblique cutting in the sense the position of the tool with respect to the work part contact will be changed. See here inclination when compared to the orthogonal cutting, which is maintaining a perfect 90 degrees by the work part to the tool. Here less than 90 degrees it is being maintained. So a slant edge of cutting phases here in the second diagram it is clear cutly visible. The slant cutting edges which is maintaining less than 90 degrees, that is either it may be of 60 degrees or 45 degrees or the 30 degrees, the material will be getting removed. That's called an oblique range of cutting. So what are the basic differences between these two? An aligned structural characteristics without deviating the mechanical properties of the material upon machining will be achieved in the case of this orthogonal cutting, particularly towards the ductile kind of materials. Whereas in this oblique cutting, the mechanical properties upon the machining process will be getting deviated. Coming to the chip flow, in both the cases and the functionality of elevating this chips in the form of MRR by maintaining the perfect ratios without deviating any of the properties either in physical range or else in the mechanical strategy towards the materials. The progress should be done. So we all aware or come to a clarity that orthogonal cutting, when the chip has which is flowing along the orthogonal plane, the inclinational factors or the deviations which will be calling the inclinational factors and the chip flow directions will be getting changed by the placement in these two different conditions, either in the orthogonal cutting or else the oblique cutting. So first one, if the 90 degrees has been framed up, the directions of these chips which has been elevated in the form of a small minute form of chips will be deviating its rack angle. Whereas in the oblique cutting, very large phase of chips which is having the high diametrical shapes or else high in its geometrical specifications, either in the length, breadth, and thickness, can have commenced in the case of this oblique cutting. Hence, the orthogonal plane will not deviate its cutting angle or inclinations. Hence, the species or direction of the chip flow or MRR will not equal to 0. Considering the pure orthogonal cutting, when it will be considered. So we have already discussed related to it that with reference to the chip flow along the pipe, which has been specified in the clearly in the diagram here, it's the pipe, by maintaining a perfect inclination of 90 degrees relates to the pure orthogonal cutting. There is a 90 degrees and not 900, 90 degrees. That's an entry mistake, which has been shown below. Where a pipe like a job is having the uniform thickness, which is turned, reduced in its length. For example, for a particular range of length, the diameter has to be reduced for this pipe, and these hashed conditions is nothing but the decreasing or removing of dirt in the form of a small chips by utilizing the turning process on the lathe machine, in the central lathe machine. Hence, the tool geometry without deviating the inclinational factor lambda that is equal to 0 and maintaining the tool contact to the work part exactly with respect to 90 degrees that result in the chip flow along the phi naught, which is also called as phi x. That is being obtained in the case of this turning process, basically turning process. Coming to the point of this chip conformation. So what is meant by chip? We have a clear-cut analysis right now. So the material upon the machining process, which is getting removed, is nothing but the chip. It will be having different dimensional accuracies. The material which has been separated from the parental material and elevating as an scrap is called a chip. So by the contact ratio with respect to the tool to the work part in different methodologies such as orthogonal cutting, as we have been seen, and oblique cuttings by maintaining different inclinational factors which can which are being machined by less than right angular specifications deviates in its geometrical specifications of the chips. So whether if those conditions has been performed, whether the surface finishing after the machining conditions will be getting in a high accuracy range or not, this best conspiracy need to be identified. So nothing but after this turning process or this orthogonal cutting, by maintaining 90 degrees to the tool, will be developing the high friction, will be having even the high frictional resistance. Upon elevating the material or separating the material for commencing this MRR, need to confide whether it is having the perfect finishing or not. So when that finishing will be achieved, either in the orthogonal cutting or else the oblique cutting, that will be clearly specified. And is there any effects that are being induced within the machining conditions or properties of the material, that will be having a clear cut understanding in the chip formation and mechanisms of chip formations. The mechanisms of chip formation. Machining is a semi-finishing or a finishing process which is done to impart or stipulate the dimensions and form accuracy and surface finish to enable the product. So the basic confines or parameters required for it is to fulfill the basic functional requirements, nothing but the electrical power supply, tool, and the conditions for it, material fixations, so it all plays a major role towards it. And to provide the better or improved performance, even render a long service life also. And even machining is a process of gradual removal of excess material, that too in the form of a chips, which will be obtaining in both the probability of conditions upon maintaining this oblique parameters by the tool to the work part, and the major index point of view, this machining is being characterized by elevating these chips either indirectly or indirectly. So it will be characterized by following some of the points. So whether the form of chips is because of in a direct conditions or indirect conditions, we will be acknowledging by these parameters. So the first parameter here it is nature and behavior of the work material under the machining conditions. So nature and behavior of the work material. So work material. So whether the operational process, if it has been done in the normal environmental conditions. So nothing but presently we are existing in normal environmental conditions. If it has been done in those conditions at a temperature, application of the pressure, force, tool parameters, and the commencement of based upon its mechanical properties, upon working process, how the material will be getting behaved. So whether it will be getting lost its parameters or properties that need to be identified, and its nature. So its nature in the sense strength, stiffness, holding, these mechanical properties, if there is any changes or not, and is there any deformation occurring due to the frictional forces which has been developed over the materials, etc. These need to be confined, and if there is any changes related to it, how to be clearly noted. And the second point is the specific energy requirement in machining work. Nothing but the energy which is required to remove the unit volume of the work material. So here unit volume refers to the feed rate which we will be imparting by the tool at the machining conditions, right? So speed by at the maintenance of a particular speed by the work part, concerned feed rate initiates the removal of the material. Right now that we are discussing that MRR process. So that will be happening at two different agitations, at the orthogonal state and at the oblique range. And here the third parameter it is nature and degree of interaction at chip tool. Nature and degree of interaction at chip tool interface. Basically, the form of machined chips will be depending directly on the work material and the geometrical conditions of the cutting tool, the levels of the cutting velocities and certain feed rates that are being processed in the working scenario. Nothing but 2 mm for an ductile materials, high depth or high feed rates can be accepted. But for the non-ductile materials or brittle kind of materials, much feed rates cannot be done, and even it has to be progressed by a detailed examining conditions. And even this machining environment leveling, levels of cutting velocity, or even the machining environment, whether the normal atmospheric range of cuttings are being processed or not, or else any of the external lubrications need to be induced over the materials. And if that lubrication has been suddenly decreasing, nominally we'll be utilizing the temperature decrement process with the help of this lubrication. When the contact has been existing in between the tool and the work part, thermal stresses will be produced by increasing the temperature. So in order to stabilize those thermal strategies, this lubrication process will be utilized, which will strengthen the material surface finishing as well as increases the tool life also. There's a basic phenomena need to be identified even at the time of machining conditions. And the basic knowledge related to the mechanism of chip formation that will help us to understand these characteristics of the chips and whether those chips are favorably attaining for the recyclation process or not can be examined in a confined manner. In the case of these ductile materials, how the mechanism will be existing, and based upon the mechanism, how the chip formation is being conditioned, will be having a detailed look. See here, during the continuous machining process, that the uncut layer of the work material just lying ahead of this cutting tool, almost subject to the sided compression. See here, material which has been removing upon the force that has been produced by this tool by maintaining the oblique condition, which is less than the 90 degrees conditions, and this is the material, and maintaining the less than 90 degrees, and hence it will be coming under the oblique range of cutting. And by that, the chip will be getting elevated in the form of a, this is the removal material. And this is the phenomena where the long stresses which are being produced and strain of the material has been considered. So deformation is getting taken place at this particular place by the inducement of high forces or high stresses inducement by the tool, at where this material cannot resist or overcome with respect to the forces that has been applied. So what are the different kinds of forces that will be applying here? See, the forces that are being applied by the tool here clearly specifies as of the tool the normal forces and the frictional forces which will be developing, and the resultant forces which will be generating upon the inducement of both the forces. Due to this kind of inducements of the stresses or forces will be calling, this shear stresses will be getting developed. So shear stresses in the sense the deviating of its angles, sliding of its angles to a particular inclination. And even that will be existing within that compressed region itself, as it clearly specifies that within that compression region itself, the process will be confined. And with different directions and different magnitudes. So here will be following or deviates with different directions, and because we can't assume in the case of this oblique cutting will be having the different directional characterizations, and in the case of this orthogonal range of cutting will be limiting to a particular size of the chip's elevation, and the chip flows of its magnitude and direction also clearly specifies. And whenever this shear stresses reaches the maximums exceeding limitations of the resistible strength values of the working material, exactly at the maximum yield stresses will be getting produced. So here this area which has been existing is the high yielding point, upper yielding point. So normally in the case of this stress strain relationship diagram, we have come across this proportional limit, proportionality limit, plasticity limit, upper yielding point, lower yielding point, and next the fracture of rupture point. So here it should be reached maximum the temperatures directly upon crossing this elasticity limit, plasticity limit, directly it will be moving on to an upper yielding point of range with the at the contact ratio of this tool and the work part, so that only the rupture conditions will be getting developed furtherly. And then it separates the material from the parental materials. But that particular forces which are causing the shear stresses in that region will quickly disappear. Only at that particular point of contact, only that much range of shear stresses also will be produced, but not at overall areas or overall work part. And even finally, this disappears when the tool rack surface has been moved on by the tool, and the chip tool engagement will be a point that will be existing and separating the chip material from the parental material. So in the form of a slices, in the form of a small slices up to a particular distance, one slice will be getting elevated, and next furtherly goes slide later on in the form of a slices. This is the result which is getting a slip or shear stops, and succeeding in the case of this compression, undergoing compression, followed for yielding and shearing strategy. And this is the basic phenomena will be existing for a removing of the material. That is nothing but the chips elevated from the parental material, indeed to get the desired geometrical specifications of the work part. And this is the phenomena which has been detailedly explained in a simple way by this Pispanen using a card analogy method. Using a card analogy method. Nothing but shifting of the postcards by partial sliding among the each other. Nothing but that cards will naturally will be having the cards and even playing cards also. When it has been power slided between one to another, obviously in the form of the slides it will be getting removed. And even by maintaining the oblique range of, in the case of this orthogonal cutting, the slices will be occurring in just like a postcards or cards shifting. But in the case of this this oblique range of cutting, that is beyond the limitations of 90 degrees, the shear and lamellar type of chips will be getting elevated. That will be having a detailed look in the diagram. And this is the model of cardinality, which will be obtaining only for the ductile kind of materials, such as lead, tin, boron, cadmium, etc. These kind of materials. The machining of these chips, even serrates will be visible at the surface levels as this following, as due to the following implications, such as the lower surface becomes smooth due to the plastic deformation upon the intensive rubbing factor by the tool over the work part at a high pressure and temperature. See, when the tool has been in contact with the material, in the diagram it is very much clear that when the tool is being getting interacted with respect to the material and decreasing its diameter, where considering the cylindrical conditions of objects, the material is getting removed, and at the contact point, frictional resistance or frictional forces inducement creates the high pressure ratio by the tool, and due to the rupture, the thermal stresses will be getting produced, which causes the removal of the material. So, in-depthly, how at what range for ductile materials, at what pressure, and by maintaining what range of temperature, the material process or removal process, MRR conditions, within the circumstances of chips, geometric conditions are being accepted, will be coming to learn very much clearly. Even the pattern of this shear deformation by lamellar in the case of this oblique range of cuttings are also indicated in different models by paper mounting, etching, polishing, even at the side surfaces of the machining chips. And these are the conditions which will be invisible to our naked eye. And we could be able to see the entire these processes which will be progress at an atomic range, which are invisible to our naked eye. And these are clearly can be examined under the microscopic analysis. Hence, the pattern and the extent of the total deformation of these chips to the primary and secondary this shear deformations by the indulgement of this tool face within the material upon inducing of the forces over the materials leads to attain a particular specifications. So on what ranges it will be getting varied, and at what axis, the machining processes will be getting deviated. We'll be having some parameters here. First one, the type of work material to be chosen, whether it may be of a ferrous type of material, non-ferrous type of material, will be having, depending upon the mechanical properties, the process need to be engaged at an initial basis. Coming to this tools, for the type of material that we are being utilizing, either it may be of stainless steel, hardened steel, diamond shaped material or cork material, and the geometry of this tool, whether it is a flat edge or right angular edge or lamellar inclinational edge or oblique shape of cutting tool, etc., has to be specified depending upon the type of working process, such as turning, milling process, drilling process. Concerned materials, geometrical specifications need to be varied. The best example is that in the case of drilling machine, 4 mm, 6 mm, 7 mm different diametrical bits will be getting elevated for its confiding of working agitations. So if at all the dimensions has been deviated, the nuts and bolts for the fixation or assembly conditions will not match it perfectly. And some other alternate need to be commenced, which will deviate the fixation concepts. And even the machining speed and feed ratios to be examined. Those are the parameters. And in order to decrease those thermal stresses at the pointal contact of this tool and the work part, in order to decrease the temperature or frictional, increase the frictional resistance without having the deflections or deviations with respect to the work part surface finishing and the tool tip of the tool, and changing of the mechanical properties due to the high temperature stresses produced at the pointal contact here. And these are the different types of parameters need to be observed in the case of different kinds of materials, and based upon the types of materials, types of tools, and its geometrical specifications beyond the type of process which we are being examining need to be characterized. And the speed concerns speed and feed based on the or which following this process will be executed. And in order to decrease the shear stresses which are being produced at the pointal contact of this tool and the work part, the utilization of these cutting fluids, you need to limit the temperature. This plays a major role, or we'll be calling a parameters, observing of these parameters at the machining processes. See, the overall deformation process causing this chip formation in a quite complex oriented. If you have been reviewed the previous machining processing conditions also by different authors, you could be able to understand whether the process can be examined in a dry conditions or wet conditions. See here, the new technical term has been came into the force. So the dry cutting process and the wet cutting process, or we'll be calling this MQL process. So MQL in the sense minimum quantity lubrication applied. So MQL, minimum quantity of lubrication provided. So without having any kind of lubricants, if the machining conditions has been progressed, it will lead to a minimal deflections in the case of this mechanical properties of the material as well as the tool also, decreasing in the strength of the tools as we have been discussed, that behavior of the material. So behavior of the material in the sense almost all the parameters will be coming into the existence. That the tool geometry may be getting deviated up to the shear range. Tool tip may get struck off. It may get sheared, and surface finishing may not be obtained in a perfect way by maintaining its high peaks, and the values will be achieving, which we'll be calling in detail as surface roughness will be achieved. And upon different experimental studies, the dry cutting process will be able to know that high temperature stresses will be produced at the contact of this tool and the work part, and to be able to machine only at the less feed rates. So 1 mm of feed rate can utilize will be minimized to 0.5 or 0.25. So by that, repeated functionalities. So instead of doing one time of MRR process to a particular length in the case of this turning machinery, has to be repeated for 4 different times if you have been utilizing 0.25 of feed rate, or else if at all 0.5 you have been utilized, 2 different types the process need to be executed. And the next, coming to the feasible, and in order to eradicate this, for example, in the case of this wet conditions, nothing but lubrication. If you have been applied the lubrications, so temperature stresses at the point of contact will be getting of this tool and material will be getting decreased. So by this we will be coming to an acknowledgement that the high amount of feed rates and speed rates can be progressed either in the turning machine or milling machine or drilling machine, whatever it may be the machinery process. So on and final, we'll be having the feasible or popular experimental methods exactly for achieving these conditions in a perfect way. So the study of this deformation of rectangular or circular grids and marked on a side surface, which will be looking in the diagram. And secondary thing, it is the microscopic study of these chips, which has been elevated from the dropping of the tool over the work part, and study of running chips by high-speed camera fitted with low magnification microscope will give the clear-cut feedback or examining at the machining area, which will be pointed with respect to the tool and the work part engagement as shown here, tool and the work part engagement, and removing of the material from the base parental material in the form of a chips. And basically this involves highly, in the case of this oblique cutting, we will be able to look at this circular rolling or circular grid deformation will be getting elevated at the tip of the tools. And even at the final stage of this deformation, there is permanent deformation, which is mostly caused by this shearing. And moreover, this circular way of chips will be getting elevated in the case of only the particular kinds of materials, that too in the ductile kinds of materials. If the strength of the materials has been furtherly increased than the ductile conditions, nothing but maintaining the stiffness at a high ratios, The chips will be getting elevated with irregular shapes, not the round shapes. The drilling process చేసేటప్పుడు కూడా చూడొచ్చు క్యాస్ట్ ఐరన్ బేస్ మీద కానీ లేదంటే మైల్ స్టీల్ బేస్ మీద కానీ రింగ్ టైప్ లో మీకు ఇక్కడ మెటీరియల్ అనేది ఎలివేట్ అవుతా ఉంటుంది. However, these ductile materials produces flat, curved or coiled continuous chips. Ring type లో మనకు వస్తూనే ఉంటాయి circular chips. So even in some cases, if the strength of the material is being existed or stiffness is having much more heavier than the ductile conditions in some of the situations, nothing but particularly that condition will be getting happened only at the alloys. So this ductile materials will be utilized as an alloys. So if alloy in the sense the steel has been put into an alloy of this ductile materials, obviously will be having increasing in its strength then compared to the only the ductile materials. Hence, the stiffness of the material will be increased. High frictional resistance need to be utilized for the plasticity range of removing the material and causing the ultimate tensile load conditions at the tool tip and the work part material that faces the high temperature stresses at the interaction of this tool and the material, particularly at this range, and produces high range of temperatures. So if the lubrication at that particular point of time, those lubrications are necessary, right? This is the different kinds of materials and what are the maximum shear stresses that will be producing towards it. And particularly in the case of this ductile materials, what are the scenarios that will be getting taken place? By the elevating of these chips, nothing but removing of the material in order to concise our limitations to the parental material, and in what shapes the application of force by the tools will be getting achieved on the removal of the material, we have discussed in the clearly in the today's class. And in the case of these alloys and non-ductile materials, which is having high strength materials such as steels, combination of steels or ferrous kind of materials, we'll be discussing in the next class. Thank you.